Today we'll be working on solving math problems with computing solutions in Study Island. Solving math problems just means using your four basic operations, thinking logically through a problem, checking your answer. Couple of strategies you're going to want to use. Mark up the question. Even when you're taking a test online, you can use the highlighters that are provided for you. You can underline with the pencil tool. Make sure that you understand what the question is asking. Always, always cross out any information that isn't necessary. You can draw a picture to help solve your problem. Always work it backwards. There's always the guess and check method. And remember to use your tools. If you've got a calculator provided for you, use it. Last but not least, check your work. So today we're working on solving real-world mathematical problems requiring addition, subtraction, multiplication, and division. Now, that just means you're looking at real problems in the real world using the four operations of multi-digit whole numbers. Just means these aren't simple ones. They have more than 2 digits. You're going to use various strategies, including the inverse relationship between operations. That means sometimes when it says to add, you know that you can also solve the problem by subtracting. You're going to use technology, use your calculator as needed, and the context of the problem to assess the reasonableness of results. That just means check your work and make sure it makes sense. So let's get started. Sam receives $4 more than Nathan for allowance. Nathan receives $8 less than Hector. If Sam receives $11 for allowance, how much does Hector receive? So let's start with what we know. We know that Sam, let me go grab my pen. We know that Sam, S is for Sam, gets $11, okay? And it says that Sam receives $4 more than Nathan for allowance. So we're going to take that $11, and that equals whatever Nathan gets plus $4, okay? Now let's go back and look at the next part. Nathan receives $8 less than Hector. So Hector here gets $8 more than whatever Nathan gets, okay? So let's start with what we know. What can I solve here? Well, first of all, this right here only has one variable in it. This one has two, the h and the n. If I think in my head 11 equals n plus 4, well, I can use inverse operations here, subtract the 4 on both sides, and I end up with n, I'll write it right down here for you, n equals 7, okay? So I'm going to rewrite the next statement. Hector gets $8 more than what Nathan got, and we discovered that Nathan got 7. So Hector gets $8 plus the $7. So what does Hector get? That's right. Hector gets $15. And it all started because it told us this right here, that Sam receives $11. So that's what I started with. Start with what you know. Now check the reasonableness of our answer, okay? If I know that Sam has 11 and that he gets $4 more than Nathan, all right, that's going to get me my $7 down here. Now that's why they put this answer here for you, to try to trick you, because some kids will do that. They'll go 11, oh wait, he gets 4 more, that's 7, and they go, oh look, there's the answer, and they circle that 7 or that C and think they've got it right because the answer's there. Those tricky test makers do that to you on purpose. Don't let them fool you. Now, if the answer were $23, that meant that Nathan would have had to earn 15. Nathan didn't earn 15. Hector earned 15. So we know that our answer is going to make sense for us, okay? So let's go to the next one. All right, Jess has read 79 pages of her book for 7 days. Which is the best estimate of the total number of pages she read? Oh my goodness. Okay, so this is a really good one for us to go in and pay attention to what it's asking. First of all, see that word estimate there? That means I'm not looking for an exact answer. I'm looking for a near answer. So when I estimate, I'm going to take this 79 pages that she has read every day, all right, and round it to a number that's easier to manipulate. Well, 79 is between 70 and 80. It's going to be a lot closer to 80 though. So I'm going to go 80 days here, okay? And she has done that every day for 7 days. She's a good reader. Now, let's see. I could, if I wanted to, go and draw a picture of this. On day 1, pretend this is a calendar page, okay? She has 80 days. On day 2, she has, 80 pages, not days. On day 3, she does another 80. On day 4, another 80. And I do this for 7 days. Gets a little monotonous, doesn't it? Yeah, we're not going to do that. We're smarter than that. We're going to take that 80 times the 7. Now, if you've got your tools and you've got that calculator available to you, I want you to punch in 80 times 7. If you don't have the tools available to you, you're going to do this the old-fashioned way. And one of the tricks is that when you have a 0 in the answer, or in the question, you have a 0 in the answer. 1 0 there, 1 0 here. I've dealt with my 0. Now all I have is 7 times 8. And I know my multiples of 8. So 7 times 8 is 56. So my answer is about, because we're talking about estimate here, about 560 pages. So now I got to look here. More than 665. That one doesn't work. Between the 595 and the 665. Is 560 between these two? No. Is 560 between 525 and 595? Yes, it is right there. But before I assume that's correct, I always got to check the last one. 445, less than 445. No, 500 is more than 400. So I know my correct answer is C, and that makes sense. Do I think about that? Let's see, 7 days, 80 pages a day, between 5 and 600. Yeah, that would make sense. Okay. Let's move to the next one. Okay, look at this question. Lance went to the store and bought 6 boxes of onions. Ew. Each box contained about 30 and 35 onions, which is a reasonable estimate of the total number of onions that Lance bought. Now this one can get tricky, okay? You actually have a couple of different problems to do to solve this one. So we know he's got 6 boxes, right, of onions. So I could draw my boxes. But how do I know how many's in each box? I do not want to just say, okay, there's 30 in this one, 35 in this one, 33 over here. I don't want to do that. I need to be a little more mathematical about it. So between 30 and 35, let's assume for a second that there's 30 in each box, and we have 6 boxes. Again, there's a 0 in the problem. There's a 0 in the answer. That leaves us with 6 times 3 is 18. So my answer is 180. Okay, so it's got to be between 180 and something else. What if there are 35 boxes or 35 onions in those 6 boxes? Now I don't have my 0 trick here. Got to think about my old-fashioned algorithm, or I can use partial products. 6 times 5 equals 30. I'm a big fan of partial products, so I'm going to do that one. 6 times 30. This isn't a 3, this is a 30, so it has a 0 here. 6 times the 3, or the 30, gets me 180. Add it all up. My answer is 210. So I got to look. My answer needs to be somewhere between 180 and 210. Is 160 fall on the number line between these two? No, it falls before that, because 165 is going to fall before the 180, so it's not that one. 193. Does 193 fall between these two numbers? Yes, it does. So that's a possibility. I'm going to circle that as a possibility, but I'm not finished yet. 225. Does it fall between the two? Nope, much too big. 218 is also too big, so I know there my answer is B. Okay? Two more to go. Daphne had a total of 76 crayons to divide up among 8 children. If Daphne distributes the crayons evenly so that each child has the same number of crayons, how many extra crayons will Daphne have left over? Oh, this one right here. See that word right there? That blows a lot of kids' minds. What does that mean, extra crayons? The question here becomes how many she has left after she divides them all up. Now, I'm going to show you something here. This gets a little bit tricky because some kids will go, oh, I know, this is a division. 76 divided by 8 equals 9. 9 times 8 is 72. That leaves me with 4 left over. Hey, look, there's the answer, 9, right there. And you would miss it because it didn't ask how many crayons each child gets. It says how many extra are left over. So that's when you have to stop and look. So you have to look at the 4 that are left over, and your correct answer becomes 4 crayons. Okay, not how many did she give to the students, not how many did she give away, or her children, but how many does she have left over. Last one. Carrie has a summer job. She makes between $46 and $53 a day, which is a reasonable estimate of the amount of money that Carrie makes after working 6 days. I want you to pause it here for me. Take a moment, work it out on your own, and then come back to me when you've got it finished. All right, I'm assuming you've worked it out on your own here. So let's work it out together. If she does $46 and she earns that 6 days, that's $46 on day 1, $46 on day 2, $46 on day 3, so on and so forth. Then we're going to use a calculator here and use that one there, 46. All right, I just start with the top number, times 6 equals. What does that get me here? I'm going to write it in. 276 is a reasonable estimate for the bottom number. Now what's the top number? $53 a day times her 6. All right. I'm not going to use a calculator on this one. I'm going to show you that partial products method again. I start on the right hand side. 6 times 3 equals 18. Write it down here. Now I think 6 times 50, because that 5 is in the tens place. 50, bring down the 0. 6 times 5 is 30. That gives me 318. So my answer has to be somewhere between these two. So if you ended up with the answer 296, you are correct. All right. All right, take a look at this last page here. You're going to click on the following link. It's going to give you a practice page. You can practice these on your own. Email them to your teacher if you would like for them to be checked. I hope that you've learned a little bit and that you feel a little bit better about completing and computing solutions in this section. After you practice this page, please go to that study island, 5th grade math, and study island compute solutions. Thank you. Have a great day.